Okay, the geometric sequence formula. Probably should zoom in on that. We need these two boxes filled in. The geometric sequence, we start with a sub n equals a sub 1 times r. We'll explain what r is if we haven't already. The n minus 1 power. So you'll need that formula. And just for continuing, we'll do a recursive one over here. The bracket you guys love to draw. Okay. Which looks like some sort of cartoon character face. But truthfully, the recursive ones, I typically don't even make you write those. Those are like multiple choice kind of things. Got that written down right now before we move on to the problem? Okay, gotta move on. Yeah. Determine whether the following sequence fits in this category called geometric. Geometric means that we are multiplying, not adding. Arithmetic was when we added the terms together, but we're not adding them together to go from one term to the next. We're not adding, but we are multiplying. Okay? Now, in the arithmetic, we had what's called a common difference, but in the geometric, we will have something called a common ratio. Ratio starts with R, which is why we use the letter R. Okay, pirates use it as well. Any term now in the arithmetic we said any term minus the previous one, but to find the common ratio it would be any term divided by the previous term. So if I take 12 and divide by 2, or 72 and divide by 12, or 432 and divide by 72, what do I get each time? 6. Therefore, I know the radius, or the ratio, I should say, is 6. No, it's not actually. No, I don't know why I said that. That was an accident. You do the next one. Go. I can, yes. So any term divided by the previous term is your common ratio. And we were multiplying by 6 each time. Got it? Okay. Your time. Work on question 2. Show your word. Thank you. No, not for you. Yeah, if you just do a few of these just to double check. Oops, sorry, that should be positive 16 over negative 4. If you get the same number each time, you do have the common ratio, which we did get negative 4. Moving on down the road. Okay, next. Find Find the sixth term of the geometric sequence. 1, 2, 3, 4, 5, 6, and we know the first one is 8, and the second one is 16, and the third one's 32. We're trying to find the sixth one. Now, I highly doubt that you are going to actually generate a formula for this. Okay? I have a feeling you probably know what the multiplier is. What is it? 2, right? Any term divided by the previous term. We got 2. So what are you probably going to do? You're just going to keep multiplying, right? What would you get for the next one? 120 what? 128, and the one after that? Any of you play 2048 in this room? Yeah, this is all 2048 stuff, isn't it? Yeah. I can't get to 4096, but I definitely, I can easily get to 2048. It's just that 4096, ooh. You know? Ouch! You play the cupcake version? Oh my goodness! Stab me in the heart. Okay, so we have done that particular question. Let's make it more interesting, because I want to. So let's find the 80th term. Okay? We are not going to continue to multiply by 2. We are going to create a formula for this. And according to the formula sheet that you just wrote on, we need to find the first term and the common ratio. Do we know the first term? Do we know the common ratio? And what do you think we're going to do for n? We're going to plug in an 80. Go. Figure it out. A lot of math. Oh my goodness. Come on. Got a big. It's going to be a big number, by the way. I'll just let you know that. Right. Come on, show me. I'm looking at your work. I don't see anybody writing this stuff down. If I had any horses, I could hold them. It said hold your horses. Wrong page. One I'm not seeing. That's scientific notation. Didn't you take a science class? Just because you're prejudiced against scientific notation doesn't mean anything. You can still do it. Ooh, this is nice. Come on. Right. It is a big number, but you can do this. Come on, folks. Oh, look at that person typing it all out. What we got? Thousands, millions, billions, quadrillions, quintillions. Man, that's like national debt stuff right there. Actually, it's way more than that. I think my number starts out with a 4, not a 9. So somebody's if your number if you get a 9 point something, you're not in the right ballpark. And it's not remember, in scientific notation, you better have something times 10 to the. You can't just put an exponent above whatever number. See, I'm seeing some things like 9.6 to the 24th power. That's not true. So this right here is not what I'm looking for. All right. I'll look, but this right here is not true. So I'm not sure how that number is coming about. So we need to make sure that we're use parentheses, or you could actually subtract 80 minus 1 and get 79. Because some of you are typing it on the calculator probably a little bit incorrectly. I'm not seeing that value. I'm not sure I understand where this number's coming from. 1264. Okay, should be doing something like this: 8 times 2 to the 79th power. Okay, so how can I read it? Okay, I have to get closer. Yes, like I can get a larger version of it. So, yeah, it's purple. I'm sorry. It shows up better on my computer screen than it does up there. Yeah. Sorry. Didn't hurt your eyes. That number on the left there might be correct. I haven't seen that version of it. It looks kind of like the version I have, so you're probably right. You probably did it on a computer and not on a calculator. The calculator would spit out that many digits. And make sure the person here on the right with the pink, you've got to put the times 10 to the. Okay, so it looks like they're on the right track, but I don't see times 10 to a power next to it. That's kind of important. Okay? That's kind of important here. What?
Subtract 80 minus 1 to get 79.
Right?
And then to get this answer,
that's good.
I had to put subtract 1 again.
Okay, now if you're going to do this, okay, use parentheses. Like come up here. All you need to do is use parentheses and go 80 minus 1. Like that. This should be correct. Okay? You don't need to worry about another minus 1. Okay, whoever did this, well done. I like it. That is a good looking answer there too. So, lots of good work here, folks. Lots of good work. Now, where'd the 95th power come? There, 24. Okay, thank you. Thank you for changing that. 4.836. Oh, there's the times 10 to the 24th coming into play. Here's a mistake you need to avoid. You can't take, it's not 8 squared. It's not even 8 times 2. You can't put 16 to the 80th minus 1. Okay? You literally need to type something like this, or like this. You can put 80 minus 1 in parentheses like that if you want to. That would work. So change that whoever you are. Got to get things. There we go. That's a good answer. That's very small, but I see your answer, and it is a good answer. Okay, moving on. Yeah, so 4.836 times 10 to the 24th is what we were looking at. Next, find the 5th term of the following geometric sequence. Okay, so what are we multiplying by? No idea. Okay, we know that we can take any term and divide by the previous term. Now, they've guaranteed you it's a geometric sequence. They're not even asking you. They're telling you it is now. So I only need to do this one time. Any term divided by the previous term. What do you get? It is negative 1/2. So every time we move forward, we're multiplying by negative 1/2. Now, they've given me the first 3 terms. How do I find the next 2? So what is 5/2 times negative 1/2? Don't give me some decimal. Because it's easy just to look at and do. No. I want you to use your brain. 5 times negative 1? Negative 5, 2 times 2? So that wasn't too hard, was it? How about negative 5/4 times negative a half? What do you think, Strubing? Negative 5/4 times negative 1/2. Come on, Strubing, you can do it. It is definitely going to be a positive 5 because you got negative times negative on the top. And it's not going to be 6 on the bottom. What else do you think it could be? 8s. There you go. You're multiplying across the bottom and across the top. Now, do you notice that those alternate back and forth? One's positive, then negative, then positive, then negative, back and forth. That is a dead giveaway that you are multiplying by a negative number. It never happens with arithmetic. It only happens with the geometric by a multiplier that's negative. Okay. Let's see here. Find the missing term of the following geometric sequence. It could be geometric. We're not going to do the geometric mean. All right, so we've got this term and then a missing term and then another term. Okay, folks. How many common ratios are we multiplying by to go from the first term to the third term? 2. So, how do I say times r times r? Wouldn't I say r squared? Hey, thank you very much. I appreciate that. I heard you before I said it. And you get 2. Please solve this for me right now. Please solve it for me right now. Go. What a fraction? Are you kidding me? When you divided by 8, what did you get? When you divided by 8, what did r squared equal? I guess maybe I should just do this with you. It sounds like it's too tough. Did you get a quarter? Because, hey, you know what drives me insane? The mask that muffles your sound. Because I would rather be able to hear everything. No, it will be a fraction. I thought there's like multiple people that are throwing things out, so I thought I was talking to one person, but evidently you thought I meant you. Yes, do we know the square root of 1? You're right, as well as that. It is 1/2. Okay, well, we'll pick this up on a different day after lunch. If you have any questions, stick around since it's lunchtime. Ms. Lehman, you're coming back so we can work on that test. But have a wonderful lunch and a wonderful day, and we will pick this back up tomorrow.